When unit testing goes wrong, it undermines one of the very principles of a high-quality app. But thankfully, your apps don't have to suffer with this problem. Today, I'll show you 10 common unit testing mistakes that I've encountered and sometimes perpetuated that will help you save time, improve your quality, and boost confidence in your work. The very first mistake that I see a lot of people make is not testing inputs and outputs. Unit tests aren't for testing every last line of code in your project. They're only intended for testing inputs and outputs. The inputs, of course, being arguments to, say, functions, and the outputs being return values or side effects. Your unit under test, such as a class or a function, are simply intended to be black boxes to your test. You only care what the end result is going to be. Now, that doesn't mean that you're going to reduce the amount of coverage that you're getting on your tests. You're simply not caring what happens in the middle. All you care about is the end result. So you can forget about everything that isn't output related. Common mistake number 2 that I see people make is forgetting to do green, red, green testing. What do I mean by green, red, green? First, you ensure that your tests can pass, and then you want to make sure that they can fail, and then you can get them to pass again. In some sense, failing tests are even more important than passing tests, because it is possible to write unit tests that simply never fail. And there's really nothing worse than that when it comes to unit testing, because you're putting a lot of trust in these tests, and they're not living up to that expectation. This practice can help catch that and eliminate that in your code. Now, in my opinion, this isn't needed all the time, but it's certainly necessary if you're exploring something new, unsure how something behaves, or if you're just getting used to a new unit testing framework. The third oversight that I see a lot of people make is forgetting to test negative cases. Now, this one might be a bit controversial, but I think it's definitely worth looking at. This is not something that unit test coverage metrics are going to find, so it's going to be up to you to make sure that this is covered. Imagine for a minute that you have a function that's just a giant if statement inside of it, and that's the only thing that it does. It's really easy to test a positive case and get the metrics showing up in your tool. But what happens otherwise? You want to make sure that your if statement is indeed working properly, so if that if statement fails, the else condition is, well, nothing happens. None of the essential code that you're looking for runs. And that's just one example, but I definitely recommend that you use discretion on this one because this can go way too far. My general rule of thumb is if you have to explicitly call out the positive case in a test, then you should probably also test the negative case. Pitfall number 4 is really easy to fall into, and that is doing integration tests instead of unit tests. In fact, this is probably the most common error that I've seen, and I know that I've done them before. I've found them in my own unit tests. To address this, let's think about what unit tests are actually doing. They're testing a unit of code at a time. So it's generally something that's very small in scope, like a function. Not a chain of functions, not a chain of classes, but only one function at a time. Then you can move on to the next function or the next unit in your code. Using mocks properly is an important way of overcoming this issue. If you find that you're starting to call other functions or other classes that aren't being mocked, then you're venturing into integration test territory. Instead, if you use mocks properly, you can forget about everything else that's outside of your unit and just focus on the code at hand. Here's an easy example for illustration purposes. Imagine that I have a login screen and I'm testing what happens whenever I press on the login button. I want to make sure that, for example, when I press the button, it calls a function on my login service. I'm not testing the entire workflow, I just want to make sure that the next step in the chain happens as expected. Point number 5 is neglecting to use factories and forwarders. Let me explain what these are. Factories are a rather common Java concept. Effectively, they're one class that wraps the interface of another one. So from a unit testing perspective, if you have a class that you can't inject with your DI framework because, say, the constructor requires something that's available at a later point in time that your DI framework can't provide, wrap it in a factory, and then you can call its constructor through your factory class later on. Forwarders are a similar concept to factories, except instead of wrapping constructors, they're wrapping static functions or static properties. Of course, with the DI tool, you can't actually inject static functions or static properties, but you can wrap them and then inject that class later on for you to test with. The factories and forwarders allow you to inject mockable components that you control inside of your code. That way, you're getting better unit test coverage in areas that otherwise wouldn't be testable. Mistake number 6 is forgetting to look at the coverage metrics. That's sort of like not looking in the mirror when you get up in the morning. How can you gauge the quality of your test if you don't know how much code they actually test? Even if you think you have all your code coverage, I guarantee you don't. Unless, of course, you're regularly looking at your coverage maps. I suggest that you run your test with coverage and then examine your coverage maps after your tests have completed. This is easiest to do on a story-by-story basis whenever you're looking at small windows of code at a time. It'll slowly improve the quality and coverage metrics of your code. Point number 7 is trusting your coverage metrics too much. Now, I know that's the exact opposite of what I just told you a minute ago, but here's an example of where it's a problem. Here is a function without any branches in it. All I need to do is run one test and check one property to get 100% unit testing coverage. However, it's clear that if I'm only testing one thing, I'm ignoring all of the side effects and I miss the real point of testing. So obviously, whenever you're doing this, you have to have a healthy balance between using the tool for what it's meant for and thinking on your feet. Pitfall number 8 is to test the language, the framework, or the operating system. This is like an integration test all over again, but it's worse because you're not even testing your own project at this point. Here's an example of a function that would be easy to overtest. As you can see, it was returning a string, but if I decide to return a null value, it actually won't compile. The language won't let me do that. So there's no point in my unit test to check that this function won't return null, because I'm guaranteed by the language that that won't be the case. All I need to do is test the contents of the result, but not the type. That's an example of over-testing the language. How about an example of testing a framework too much? I commonly use a library called RxJava, and this is used to help me orchestrate a series of complex steps in a particular order. So whenever I unit test this, I'm not making sure that RxJava is able to go from one step to the next onto the next. All I'm doing is testing my work. RxJava has plenty of unit tests on its own, so I'm sure they've already tested that it can drive a workflow from one step onto the next. I don't need to retest that. Oversight number 9 is admittedly a little embarrassing. It's just copy and paste errors. I still make this mistake. I've found that this is a really common mistake for me to make whenever I have similar functions in my code with just slight changes in them that I need to test. This is really common whenever I have branches in my code. So for example, if I have a certain set of tests for a positive case, I might copy that code and edit it just slightly for the negative case. Whenever I copy and paste a block of code, I need to make sure I'm actually testing the right thing. I know this seems basic, but it's really something I slip up with a lot. Am I actually calling the new function or the new branch, and have my descriptions been properly updated? Well, those are things I need to check. A great way to verify that this is working properly is to go back and do your green, red, green testing. And that leaves us with just our last issue. And that's whenever I say I'm going to write unit tests later. Really? Am I actually going to come back and do these tests later? Or am I going to move on and do something else that's more fun? I've said this before when time constraints are tight, but this is really a slippery slope. So whenever I come back and say I'm going to do it later, I need to make that soon, or later will turn into never. Here's how I address this to make sure that I don't forget to do it. First, I make some development tasks, and then I put them on my board. Not on my backlog, because that can be a bit of a black hole sometimes. I make it front and center and put it on my board. Then I make it a top priority to readdress this as soon as there's an opening. It's fine to say that you're going to write unit tests later, as long as you have a good reason for it and a follow-through action plan. This is not fine to say if you're just kicking the can down the road and you don't have a follow-up plan. Because trust me, later will then become never. With 10 new tools under your belt, you are now more equipped to write better unit tests that will provide more quality to your app. If you'd like one more tip to make unit testing on Android easier, but just as thorough, continue on to this video here. I hope to see you next time on ThoughtFuel. Thanks, and happy coding.